Hi, in this video we're going to talk about the compose function with inverse function. So if we try to compose with an inverse function, so we will end up to getting the output out. But if it's the opposite, we're going to compose the original function with the inverse function. We're going to solve for x. So this true is always true. Okay, let's do a quick reminder why this is a y inside. Because remember that the inverse function, we swap x and y, so that means that y is become the input for the inverse function. That's why the independent variable for the inverse function is going to be y. Okay. Now, the second thing that I want to do a quick review is the restricted domain for the sine and the cosine and the tangent function. So for sine function, the domain should be restricted between negative pi over 2 to pi over 2. Negative, this is a negative. And then from cosine theta, the restricted domain should be from 0 to pi. And from tangent is not including at the endpoint, which is negative pi over 2 to pi over 2, because the endpoint is a asymptote. Okay, now for the inverse function, arc sine theta, the output, not theta anymore, this has become the ratio. The ratio should be between what? -1 to 1, whereas the inverse function of a cosine, it will also be from -1 to 1. And for the tangent inverse function, well, if you remember the graph, which is going all the way up and all the way down, so that means this is from -infinity to infinity. Okay, so that's a quick review. There's two things that we can remember and use when we're doing the composite function, when we're solving it. One is the order of operation. We always start with whatever inside the parentheses first. Secondly, we need to use the reference angle. Okay. Now, let's try this. The first one, the sine inverse of sine pi over 2, and let's say this is equal to what? First, we need to follow the order of operation. That means I want to calculate inside the parentheses first. Sine pi over 2 is equal to, pi over 3. Sorry, pi over 2 is 1. We can do this one. We can do 1. 1 is fine. Let's do 1, since I already said 1. Pi over 2. Let's do pi over 2. Sine pi over 2 is equals to 1. So the arc, which is the inverse, sine 1 is equal to what? Remember that this has to be in the quadrant 1 and the 4. Well, 1 is fine, because when sine -1 equals to 1, that still gives us pi over 2. Done. We solved that. Okay. Second one, I have arc sine, and then the regular sine 2 pi over 3. Okay, this one is going to be a little bit harder. First of all, sine 2 pi over 3 is equal to what? Now, let's try to draw this, because I already asked you to memorize all the special angles numbers. Okay, 2 pi over 3 is equals to, if we rewrite it, is equals to half pi plus 1/6 pi, right? So that means after half pi, you need to add another 1/6 pi in it. So this should be 1/6. And the totally, this is 2 pi over 3. Okay, so what's the reference angle? So the reference angle, which is theta prime, is equal to 1/3 of pi, which is 60 degrees. Sine 60 degrees is equal to, that's not hard, square root of 3 over 2. But since it's in the second quadrant, that means this has to be negative. Now, when it comes to the inverse function, we need to be careful because we want to restrict this whole thing. The domain is between negative pi over 2 to pi over 2. So that means it has to be on the first and third quadrant. Also, I made a mistake. In the second quadrant, sine is still positive because sine is the y value, y coordinate is still positive because it's above the x-axis. Okay, well, this can still between the square root of 3 to over 2. How can the inverse function, if the inverse function squares 3 over 2, so that means the actual value should be what? Well, it can only be the first quadrant or the fourth quadrant, which means only to be in this part. And since it's positive, that means it has to be in the first quadrant. So we know that this is going to be in the quadrant 1. So in quadrant 1, and the ratio is square root 3 over 2. So that means this is going to be pi over 6. No, over 3. 60 degrees. Because we want the answer only be able to be in first and fourth quadrant. And this is a positive number, so it has to be the first quadrant. Okay, let me show you a third example. A third one, I have the inverse cosine and then compose with the original cosine 2 pi 3. Okay, follow the order of appendix, which is we want to do the whatever inside the parentheses first. So this part is 2 pi over 3. So that means the reference angle is going to be pi over 3. This is in the second quadrant. That means pi over 3 is going to be a negative for cosine. And the pi over 3 is 60 degrees. So that means the cosine of 60 degrees is equal to 1/2. Okay. Now, the second part is we try to solve the inverse function. First of all, let's do a quick review. The inverse function has to be in the domain from 0 to pi, which in this case would be easier because your angle already in the second quadrant. Okay, so this part, it will be satisfied for the inverse function. So that means the inverse function angle has to be in either first or the second quadrant. Secondly, we know that the ratio is negative. That means it's going to be in the second quadrant. Okay. Now it's in the second quadrant. Now we need to think about which value will give him 1/2. Well, then we need to use the second things, which is the reference angle. So if the reference angle cosine theta equals to 1/2, that means theta is equals to pi over 3. It's going to be the reference angle. So that means here would be the reference angle, this part, also pi over 3. So that means it's still in the second quadrant, which is satisfy the domain. So that means the inverse function, it will be the same as what we have in here, 2 pi over 3. Now, let's do a fourth one. If I have a cosine inverse function of cosine 2 pi negative pi over 3. Let's do something different. Okay, follow the order of appendix. So we compute what we have inside the parentheses. So this is the fourth quadrant because it's going down. And then cosine, we use the reference angle, pi over 3, it gives you 1/2. And the cosine in the first quadrant is still positive. So that means it will give you 1/2. Now, the domain. The domain of restriction for the inverse cosine function, it will be from 0 to pi. So that means we expected our value is in the first or the second quadrant. Okay, so now we have a cosine 1/2, which is a positive. So that means it has to be the first quadrant, because if cosine is in the second quadrant, you would expect the ratio would be a negative number. Okay, if the output is 1/2 in the inverse function, so that means the input, the measurement should be, for cosine, would be pi over 3. That's it for this video. Let me know if you have more questions.